Okay, this is gonna be different, but a lot of stuff going on right now. I appreciate that you guys are here. I guess I should just say that I've found in times of uncertainty, it's comforting to do something that's part of your routine already. And teaching math is part of my routine. So again, I appreciate you guys getting out of bed and coming to class. And let's get to work. All right, so in order to be able to factor these polynomials, we will have to work on our skills of finding the greatest common factor, the GCF. This is something that you've been doing for a few years now. So let's think about what the greatest common factor is between a couple numbers, like let's say 24 and, I don't know, 16. 16. Okay, so remember the way we would do this is we would break this apart. Maybe you're thinking about it with the factor tree, okay? Maybe you don't need to, but maybe you do. So think about what all the numbers are that could multiply together to make this. Or at least think of two numbers that can multiply together to make this. 4 times 6. 4 and 6, they multiply to make 24. Okay, cool. Let's keep on breaking it down. So 2 times 2 is 4. 2 times 3 is 6. And we can't break this apart any further. These are all prime numbers. Okay. We'll do the same thing with 16 and break it apart. Let's think like, that's 2 times 8. All right, 2 can't be broken down any further, but 8 can. It's 2 times 4, which is 2 times 2. All right, so if I were to rewrite this, make it a little bit more organized like this one, I could see that we've got 2 times 2 times 2 times 2, okay? Over here, we had 2 times 2 times 2 times 3. So really, one of the best ways to find the greatest common factor is by circling all the factors that these two numbers have in common. I'm going to circle 3 of these 2's, not all 4, because this number 24 only had 3 2's. The greatest common factor of 24 and 16 is 8. Because 2 times 2 times 2 is 8. Finding the greatest common factor. It's basically going to work out the same way when there's variables involved. Let's just break these terms down. The 6x has, a 6 times an x. A little weird. We don't know what the x is, but we don't need to, okay? The 6 is really 2 times 3. So altogether here we have 2 times 3 times x. Those are the factors of 6x. If we break apart x squared, oh my word, how does this work? We don't know. There's no constant number to the left of the x. There's no coefficient there. That actually makes it easier, okay? The two factors are x and x, just x times x. So again, things look strange in math quite often. We're not really sure what to do, but let's try to back up to the general concepts involved. The general concepts involved here, or the steps we were doing just before this, are break it down to all the numbers that multiply to make the bigger number, and then see which ones they have in common. X, in this case, is a number. We don't know what it is, but it's a number. It's a term, okay? So there's an x here and there's an x here. And that's really all that we see that they have in common. So, yeah, the greatest common factor on these two terms would just be x. There's no regular numbers on this one. There's only one x on this one. So that's it, x. Over here, 4x squared and 30. Let's break this apart. You're thinking to yourself, okay, what are the numbers in both? What are the variables in both? Oh wait, I've got a little x squared right there. This is x times x. And maybe at some point you think, wow, that's too much. I don't need to do all that work. Again, cool, good for you. Then make sure that your shortcut works and move on. So 30 is a fun one. A lot of ways we can go with this. I like to go for the numbers closest to each other. 2, 3, and already you're thinking like, there's no variables here. Okay, that's fine. I'm gonna look here and see what they do have in common though. All right, so it's 1, 2, and no x's over here, so that's it. 2. No distractions, please. We've got 2 terms here that both have numbers and some variables. Let's figure this out. Maybe we will start to think of shortcuts. All right, 12, 18. What number goes into both of these? What's the largest factor in both of these? I think it's 6. Yep, 6 times 2 here and 6 times 3 here. So I could keep breaking it down further, but I really don't need to, all right? So that is a shortcut. The moment I see the largest number that goes into both of them, I could stop right there, okay? Oh, and I broke it with the 2 arrows here. I'm gonna do a 3rd arrow. Hopefully you're fine with that. And seeing that it's really a bunch of x's. Skip ahead a bit to the other factors. Okay, and so maybe we're seeing now the numbers 6 and the variables, we only have the 2 x's right here. Okay, x squared for the term on the right, x to the 3rd on the left, but we know that x squared will go into x to the 3rd. It has at least 2 x's. Let's put all this together. For both of them, it would be 6x squared. A little quick there, a little bit of a shortcut. But again, let's notice that the number that will go into 12 and 18 is 6. That's the largest number, the greatest common factor. And the x's, we don't know exactly what x is, but we know that there's at least 2 of them multiplying together in this one, an x squared. And in this one, there's an x squared as well. There's actually a 3rd x multiplying, but there's not in this one. So 6x squared. No candy. All right, so if we're gonna factor this polynomial, we really need to find the greatest common factor, okay? So if we think about breaking apart the x squared and the 9x, it's really just x. X is the only number or letter they have in common, okay? So what we would do is we would pull that out of the parentheses, okay? There would be an x out here. We would think about dividing these 2 terms by the term we're pulling outside the parentheses. So x squared divided by x is x, plus sign stays there. 9x divided by x is 9. So, like I said at the very beginning, we're using division to break this polynomial into its factors. And like I've talked about before, always thinking about how multiplying and dividing are the same type of thing, but in an opposite direction. So if we think about this now as multiplying, going the other way, multiplying these polynomials, if we were to distribute, yeah, we get x times x is x squared, and then x times 9 is 9x. These are the 2 factors that would multiply together to make x squared plus 9x. What? Scotty, any questions? Okay, so if we're gonna factor this polynomial that has coefficients and variables, maybe shortcut we could use that you might like is just focusing on the numbers for right now. So 16 and 6, breaking that apart. Why don't I start with the smaller number? It's 2 times 3, so we're just looking for those. Okay, I mean, this could break down as 4 times 4, but why don't I go for one of these numbers right off the bat? 16 is 2 times 8, so okay, 2 is the greatest common factor. 4 wouldn't work for 6, it's got to be 2. So I know I'm going to pull 2 out. Sitting down, please. Thank you very much. May I continue? I can start to set this up how I know it should look. Even this minus sign right here, okay? Now let's think about the x's. It could just be as easy as circling the variable with the lowest degree. Ooh, the lowest degree, new terminology. We could just say the variable with the smallest exponent, okay? That's what's gonna come outside. The exponents on the variables, a little bit easier. We basically just look for the smaller one because that is how many times x is multiplying together. That is how many x's there are as factors. Exactly 2 here. There's 5 x's here that are all factors, but 2 x's here that are factors. So altogether, I would be pulling out 2x squared. If you haven't noticed by now, there's the focusing on the numbers and the focusing on the letters. So for the numbers, let's focus on that. If we're doing 16 divided by 2, we're left with an 8. 6 divided by 2, and we're left with a 3. We could think, oh wait, there's a negative sign there. Mr. President's always talking about how the negative sign is connected to the number. It's not subtraction, it's a negative, okay? In that case, if we're thinking about negative 6 divided by 2, yeah, it would be a negative 3 still, where whether we're thinking of it as a negative or subtracting that number, it's gonna work either way. No talking, please. Thank you. Okay, now focusing on the x's, the variables and their exponents. A little bit easier over here. Something divided by itself is just 1, okay, and I don't need to write that. But x to the 5th divided by x to the 2nd, while you're thinking about that, why don't I just put this up here? We might remember back to our discussions about exponents previously. We could look at it as a division problem. X to the 5th divided by x to the 2nd, all right? Maybe we're thinking about how we subtract those exponents. Maybe we're in doubt, so we're expanding it out. I'm not sure. 5x is up here. Getting a little sloppy, Mr. President. That's okay. 2 down here. Pick a cool, fun new color. We're canceling out 2 pairs. We are left with 3 on the top. Or again, the shortcut, x to the 5th divided by x to the 2nd. 5 minus 2 is 3, okay? If we are going the opposite way, now this is our answer. Why don't I box it? To make sure we know that this is our answer, okay? So if we're going the other way and we're thinking, oh, multiplying polynomials, multiplying these 2 factors together, the numbers in purple, the 2 times 8 would give us 16. The 2 times negative 3 would give us 6. And as far as the variable, x to the 2nd power times x to the 3rd power, yes, opposite of this. Let me check it out. Remember what we do with those exponents. We add them together, okay? Just add those to get x to the 5th. So that would work out if we're going the other way, getting x to the 5th power. And a little confusing, what's going on here? There's no x here. That's okay. If we're distributing 2x squared to the negative 3, we do get the negative 6, and all of a sudden there's an x squared there as well. So again, noticing how we used division to find the greatest common factors for both the numbers and the variables, okay? And the discussion at the end was just about how going the opposite way, multiplying would have given us the original polynomial that we started with. Leo, outside. Okay, hold on. Go over your notes. Make sure you go over the Google Slides. Do the IXL. Make sure you do your IXL. IXL, sponsor me, please. Okay. Don't follow me. I got to deal with this. Do follow me, but don't follow me.